in the last segment, I introduced the first percent unit, which is mass by mass. And you would use this unit when your solute and your solution are measured in masses. But the rhetorical question is when would you express water and therefore the solution in terms of grams? Well, you wouldn't. So that introduces our second percent unit, which is percent volume by volume. And you would use this unit when your solute would be most easily expressed in volume units, and your solution would be in volume units. So examples would be two liquids. So a good example would be, for example, alcohols. Alcohols that are familiar to us. Okay, so I have some rubbing alcohol or isopropyl alcohol. Okay, so that's a liquid. And I want to know about concentration if I pour some of that into some water. So volume by volume would be a unit that I would use if I take an alcohol, such as rubbing alcohol, which, by the way, is not the same alcohol that you would consume. By the way, never consume isopropyl alcohol. It will oxidize into acetone. Acetone is nail polish remover, so don't do that. Okay. However, if you're going to consume alcohol, it is similarly in liquid form. Okay? So that's what I mean by this. All right, so alcohol, consumable alcohol, which is ethanol, I want to be crystal clear, ethanol, not isopropanol, or isopropyl alcohol, is in milliliters. And then your wine is your solution. Again, wine is not water. They're totally different. Okay, so you would use this unit, percent volume by volume, put the milliliter unit in the numerator, 100 milliliters in the denominator of your wine, that's your solution, not the water, times 100%. And your wine is 12% volume by volume, or 12% alcohol in that 100 milliliters of wine. Okay? Now, what this should alert you to is that all of these have a unit in the numerator, unit in the denominator, so all of them can be used as conversion factors. Okay? So I've written one here that will use this percentage as a conversion factor. So, for example, if you have a 250 milliliter glass of wine, okay, so 250 milliliters is about 1 cup, okay? By the way, 1 cup is more than a standard serving, just as an FYI, which we'll get to down here. And it is 12% alcohol volume by volume. How many milliliters of alcohol are there in that glass of wine? Okay, so we're going to set this up as a conversion. We have a 250 milliliter glass of wine over 1, and we want to know milliliters of alcohol. That brings us to the percent, because the percent is milliliters of alcohol over 100 milliliters of wine. So whenever you see a percent, you can say it's that much over 100. Okay, so I'm going to have 12 milliliters of alcohol over 100 milliliters of wine. Milliliters of wine will cancel, and what I end up with is 30 milliliters of alcohol. Now, most people, most of the time, in this country at least, have a tough time perceiving 30 milliliters. Okay? So what I said down here is a standard serving of alcohol is 1 ounce equivalent. If 5 milliliters equals 1 teaspoon and 3 teaspoons equals 1 tablespoon, how many tablespoons of alcohol has this person consumed in this 1 cup of wine? Okay, So the 1 ounce equivalent is not entirely germane because none of this talks about ounces, okay? However, we're going to start with this, 30 milliliters, and we want to convert that into tablespoons, okay? Because tablespoons, most people most of the time can wrap their head around. Okay, 1 teaspoon is 5 milliliters. Milliliters will cancel. 1 tablespoon, 3 teaspoons. Teaspoons will cancel. 30 divided by 15 is 2 tablespoons. Okay, 2 tablespoons. So this glass of wine would be equivalent to taking 2 tablespoons of 100% alcohol, which would be like Everclear. Okay? What is the percent volume by volume of 25 milliliters of ethanol in 233 milliliters of ethanol octane solution? Okay, so first of all, we have a milliliter here and a milliliter here. So even if we don't know what ethanol octane solution is, we would use volume by volume. Okay, so percent volume by volume equals 25.0 milliliters divided by 233 milliliters of the solution times 100%. We push some buttons on our calculator and we find that this is 10.7% volume by volume. Okay, so the question here is, where would you find this type of solution? And this is what we would generally refer to as gasoline that we would put in our car. And we definitely do not want this to be aqueous. Okay, so here's just an example of something that you absolutely don't want any water in. So not all solutions are aqueous, but it's a good starting place for us. Okay, now the reality of it is this is all great and well and good and all, but how many things do we encounter in our lives are going to be something that's a volume that's dissolved into something else that's a volume? Well, that's also rhetorical, because a more typical unit is when we have something that's solid. We're going to have some sugar, and we're going to put that in our coffee. We're going to have some crystals of Kool-Aid, and we're going to put that in our water, and we're going to make our Kool-Aid. We're going to take a vitamin, okay, a vitamin, and then we swallow it. We're going to put it in our body. Our body is a water environment. So usually and typically, the solute is some kind of mass unit, and the solution will be some kind of milliliter or volume unit. So this one is more typical when you have a solid substance dissolved in something liquid like water. Okay, so you swallow your vitamin, you want it to be absorbed into your blood. Okay? So in the next segment, we'll work on some problems that you will see in a more usual and typical application using percents.